Today's lab we're going to synthesize an azo dyestuff called Para Red, and it's kind of a two-stage process. We need to carry out a diazotization, and for the diazotization you'll need 2 small beakers equipped with stir bars. We'll need a couple of small graduated cylinders, pipettes wouldn't hurt, 50 milliliter graduated cylinder or 25 for the diazonium salt. We need to chill that into an ice bath. I'm going to use just a plastic container here so that I can put this on the hot plate and stir it. And we're not using the hot plate portion, we're using the stirring portion, but this needs to be with ice in it. And then for the coupling component, we'll need the graduated cylinder and a beaker, a couple stirring rods. We're also going to make the dye stuff in some test tubes, and so you'll need 1 or 2 test tubes there. And then fabric, which we'll get later when we're ready for the dyeing process. And also a couple of thermometers just to make sure we keep the temperature of the diazo component down to around 0 to 5 degrees. Today's lab we're going to synthesize a dyestuff called Para Red, and this is the structure of the Para Red. It is a type of azo dye. And whenever you see the term azo, azo always refers to this nitrogen, double bond nitrogen within a structure. Para Red, if I'm not mistaken, I believe was the first azo dye stuff known. And azo dyes in general, I would probably say are the most important class of dye stuffs. They probably contribute, I'm going to say around 60 to 70% of all the dyes that are known. And they pretty much cover the whole gamut of the visible region of the spectrum. You can have the yellows up to the orange, red, blue, indigo, violet. And they're typically used a lot for cellulose, but they're also used for food dyes and up to textiles such as cellulose and anywhere in between. So they are a very widely used class of dye stuffs. In order for us to synthesize this azo dye, and the reaction is really an electrophilic aromatic substitution reaction. To synthesize this dyestuff, we need 2 components. We need something that's referred to as a diazo component, and typically your diazo component has to be something that can undergo what we call diazotization. The diazo component are typically aromatic primary, I should stress primary aromatic amines. And so the diazo component we're going to use today is the para-nitroaniline. So when it undergoes diazotization, this is actually to make it form or turn it into a better, and turn it into an electrophile in general. And that's what we need for an electrophilic aromatic substitution reaction. When we treat the para-nitroaniline with a sodium nitrite and hydrochloric acid, and it's very important to keep that temperature between 0 and 5 degrees, then that primary aromatic amine undergoes a diazotization reaction to form this diazonium salt. We've got N2 plus and Cl minus. This is what is going to serve as our electrophile and the electrophilic aromatic substitution. Just want to say one thing about keeping this at 0 to 5 degrees. Diazonium salts are not very stable in general, so it's very important that you keep that at 0 to 5 degrees. Light can facilitate their decomposition. Sometimes if you were going to do this reaction and let it stir for hours on end, I would probably wrap that beaker in foil paper just to protect it from light. We're only going to stir it for 15 minutes. You can pretty much tell if it does decompose because you would see bubbles rising to the surface, and that's because it's releasing nitrogen gas, and you would see that. So this is our diazonium salt. And then the other component is called a coupling component, and your coupling component has to be some type of activated aromatic compound. It could be benzene or a benzene derivative. Notice here we're using naphthalene. We're using 2-naphthol, or some people call it beta-naphthol. But when we say activated, typically you need something that can donate electrons into that aromatic system. Usually the best ones are hydroxyl groups, or you could have amino groups as well. So what we want to do, since this is hydroxyl group, we want to treat that with sodium hydroxide to form the sodium salt. We need that to dissolve in our aqueous solution. So this is our coupling component. This is our diazonium salt that was derived from the diazo component, which was that primary aromatic amine. Then once we get these both in the right temperature and the right acidity, basicity, if you will, then we can do two things. We can mix these together, and I'm going to do both things. I'm going to mix some of the diazonium salt and some of the coupling component together in a test tube, and we'll automatically form the dye stuff. Now, if you wanted to, you could filter that through a Buchner funnel and actually have that filter cake that would serve as your dye stuff. We're not going to that. I just want to mix it in a test tube so you can see the color of the dye stuff form. The other thing that I want to do is I'm going to take some of the coupling component. I'm going to take a piece of fabric, cotton. I'm going to immerse it into the coupling component, squeeze out any excess, let that dry for a few minutes. Then I'm going to immerse it into the diazonium solution. And what happens at that point, the dye stuff will actually form on the surface of the cotton, so we can see that as well. I will say one thing about dye stuffs that are used especially for cotton, if they're these azo dye stuffs, unless they have a functional group on that molecule that actually forms a covalent bond to the cellulose or cotton, they typically don't have very good wash fastness. And what we mean by wash fastness, every time you wash it, you notice that color fades and fades and fades over a period of time. There are certain classes of azo dyes that are called reactive dyes. They're used a lot in draperies and that type of textile. And if it's a reactive dye, there's a functional group that actually forms a covalent bond to the cellulose, and they usually have superior wash fastness. You'll probably see the dye stuff today doesn't have much wash fastness, especially when I rinse it, but just kind of gives you, there are some things you can do to improve that. That's beyond the scope of what we're doing today, but just to give you an idea of how you can make a dye stuff and how you can actually make the dye stuff on top of the fabric. The first step in the dye synthesis is that we need to prepare our diazonium salt. And so what I have here is 1.005 grams of the para-nitroaniline. I put that in a small beaker equipped with a stir bar. To that I'm going to add 25 milliliters of water. And then also 1.2 milliliters of concentrated hydrochloric acid. Usually the amount of hydrochloric acid we add in diazonium salts is typically around maybe 2.5 times the amount of our diazo component that we're using. We just want to make sure that we have complete diazotization. So I'm going to stir this and try to get all that to dissolve. Once it's all dissolved, I'm going to use this as my container for my ice bath. I'll put that underneath there and then chill that down to 0 to 5 degrees. May take a few minutes. Para-nitroaniline is one of those substances, even though it has the NH2 group, that nitro group really limits its solubility. So it may not completely solubilize. It typically will as we add the sodium nitrite solution to it, but we'll try to get as most of that in solution as we can. So I'm going to let that stir for a few minutes and then we'll come back and take a look at that. In the meantime, I've got, because what I have to add to that once it's chilled, I have to add a solution of sodium nitrite. So the sodium nitrite I've already weighed out as 1.011 grams, and I'm going to dissolve that in 5 mils of water. And then once the diazonium compound, the azo compound, is dissolved and chilled to 0 to 5, I'm going to add this solution to it, and then we'll chill it, keep it chilled for another 0 to 5 degrees for about 15 minutes. I have the para-nitroaniline that has the water and the hydrochloric acid. I put that in an ice bath and waiting for that to chill down to 0 to 5 degrees. I need to make a solution of 1 gram of sodium nitrite and 5 mils of water. I have a little bit over that, 1.011 grams. I'm going to add the 5 mils of water to that and then dissolve that up. Should dissolve pretty easily. And then once that's dissolved, I'm going to put that in an ice bath because that needs to be chilled to 0 to 5 degrees as well. So when we come back, we'll keep a check on the temperature. Once they're both at 5 degrees, 0 to 5 degrees, I'll add the sodium nitrite to the para-nitroaniline and the HCl, and then let that stir for about 15 minutes. We're at 0 to 5 degrees of the diazo component that was dissolved in the aqueous hydrochloric acid. And then here's our solution of the sodium nitrite dissolved in water. I'm going to take the stir bar out and simply dump this into my diazonium salt and let that stir for 15 minutes. So we'll come back and take a look at that then. I've weighed out our coupling component, which is the 2-naphthol, and I've got 1.019 grams of that into a beaker. To that I'm going to add 50 milliliters of a 10% sodium hydroxide solution. You may notice that it looks like there's some particulate matter that's floating around in there. Sometimes when solutions sit over a period of time, they crystallize, the solute crystallizes out, so we probably have some undissolved sodium hydroxide. I'm not going to worry about filtering that. We'll just go ahead and use it as it is. So I'm going to add that to the beta-naphthol or 2-naphthol solution. And then we're going to stir that. It's not critical that we chill this down. It's primarily just to protect the diazonium salt, but once we have the coupling component ready and after the 15-minute time period is over, we'll carry out the dyeing process and also the making the dye stuff in a test tube. So it's been 15 minutes of stirring the diazo component with the sodium nitrite, HCl, paranitroaniline. So, and then over here, I made the solution of the 2-naphthol dissolved in the 50 milliliters of 10% sodium hydroxide. So the first thing I want to do is, and we're not doing a percent yield or calculating how much we got, but I just want to show you how you can actually make the dye stuff. Typically, if someone wanted to do this and all they were interested in was making the dye and collecting it, they would add one to the other, stir that for a certain period of time, and then filter the precipitate that form. What I'm going to do, I'm just going to do it in a test tube because I want to also do something else with these beakers. So I'm going to take some of my, and it doesn't matter, I'm not just pulling some up in a pipette. And then I'm going to take some of the coupling component and add to that. And take a look at that dark red dye stuff. So this is a solid, you can't see through it, and I'm not sure if you can see the actual solid, it may be hard to see. But this is the dye stuff, this is the para red that we just made. So think about this, if you wanted to make this and isolate the dye, you would simply combine those two together, let them stir for a while, and then collect it by vacuum filtration. So this is how you can make the dye stuff. What I also want to show you is how you can take a swatch of fabric, this is just a piece of cotton, and what I'm going to do is to immerse this in the sodium hydroxide solution of the beta-naphthol. And again, no matter what experiment you're doing, you always wear gloves, especially today when we're using a fairly high concentrated solution of sodium hydroxide. I'm just going to take a stirring rod and then just kind of put this piece of cotton inside there. Kind of move it around, let it get saturated. And then what I'm going to do is take this out. I'm just going to squeeze out the excess liquid. And then I'm just going to let this air dry just for a minute or two. And then what I want to do, once this kind of air dries a minute or two, I'm going to put it in the diazonium solution, and then we'll see how the color forms on the top of the cotton. So I'll let this air dry for a couple minutes. We could maybe let it dry longer, but I'm just going to go ahead and put it into the diazonium solution, and we'll see what happens. And as you can see, we've formed the dye stuff on the cotton has combined with that. Now this is not a true chemical bond. This is more of a intermolecular interaction, if you will. The other thing I want to point out that I just kind of wadded this up and put in here, so certainly it may not look level dyeing, but in the real world, what some companies do, let's say they had this piece of fabric, and of course they would be looking at thousands and thousands of yards of this. They would put this on some type of roller, they would immerse it into the coupling component, then it would come up, probably air dry a little bit, and then it would go into the solution of the diazonium salt, and then you've got the dye stuff on the fabric. I'm doing this on a small scale, but you can see it's a pretty decent color saturation on the cotton. And again, anytime you need to certainly change your gloves, dispose of the waste in appropriate waste containers.